Let's look at this problem. It's geometry, so I'm looking at this R1. Okay, PQR is the tangent to the circle, and ST is parallel to QW, and VT is equals to VW. We are given S2 as 30, W1 as 70. Determine the size of VU and Q and T. Okay, so first of all, as you can see here, we have to know the sum of the theorem. This theorem, opposite angles of a circle quad. This angle, it's when you combine this one plus this one, it have to give you 180 according to the circle quad opposite angles, and this one and this one. So we have to look something like this from this problem. When you combine the opposite angles, so according to circle quad, so you have to look something like this. First of all, to check which one is given here, and then we have what you want, and then we have this one and this one. Like here we're given S, and then they are looking for V. As you can see, this one make a circle quad, so we have to check something like that. But what we know that this angle, it's equivalent to this one. Raising their alternating angles. Okay, let's start it. So starting with this one, as you can see from this point, we are given this one as 70. This, because they are parallel, they are equivalent, that's why you can apply this one. So W1 is equals to S1 because they are alternating angle, so this side is also 70. If you know the alternating angle, you have to know this in order to solve this theorem. So we can say angle S1 equals to W1 equals to 70, raising their alternating angles. So we have this S1 which is here. So we have one of the problem here, and we are going to alternating angle because ST is parallel to QW. If they are parallel, we can able to apply the alternating angle because they are equal in angles. So we know by the circle quad that and then here it's 70. This is opposite angle of the cycle quad. This is the reason we say this one equals to, if you can check, you will see those angles. and so we can solve for V, because the first question needs to be, so subtracting 70, you'll have 110. So we are done with V, and then let's check number 2. Number 2, they are looking for Q, the size of Q. Looking for Q1. So Q1, it's equals to W1 according to the Tan-Cot theorem. It says this angle is equals to this angle. So you have to know this theorem before you solve this one. So this angle here, it's equivalent to this one, and then you're looking for Q1. So we would say reason is a Tan-Cot. So number 2 itself. Number 3, you want T. Where is T? T, it's here. Right. So we have to apply the angles inside here. Angles in a triangle, it's 180. Angle of triangle, all of them, if you add them, they have to give you 180. So this is another part that you have to know it. So because there's T here, so you have to find T. You're actually looking for T1. T1. Because these lines are parallel. But we know S1. The other two we don't know. Or we're given S2. If we can find Q2, as you can see from here, this is the angle inside the triangle. We have most given one, we have this. We are dealing with it. So we say you have something like this. Then solving for Q2, we'll have 80, and then reason for this one, it was angles of a triangles, they all give you 180. Okay, then now we have so T1 plus Q2 equals to 180. So we have reason being, as you can see, this form a cycle quad. This is a cycle quad. Angle that form 90 degrees, the opposite angle that form 180 degrees, these angles. So this is the reason behind this. Okay, this is 8, so then you will have your T1 as 100. So if you like this video, just press the like button. If you want more video like this, just subscribe to the channel. So thank you for watching, see you on the next video.